Hello everyone, I welcome you back to this channel. If this is your first time of joining us or seeing this, you are welcome. My name is Victor Brimo. We are into sales and installation of solar system and into online training. I encourage you to subscribe to this channel, endeavor to watch our previous video, and also hit the notification button so you can be notified of our subsequent videos. In today's episode, we'll be discussing the main differences between PWM and MPPT solar charge controller. And what is even charge controller? A solar charge controller is an important part of an off-grid solar system or a battery-based solar system, as it ensures the safely and efficient charging of our batteries. And this charge controller is divided into two. We have the PWM and the MPPT. The PWM stands for pulse width modulation, while the MPPT stands for maximum power point tracking. So we are going to categorize these differences into three main groups. The first one is the mode of operation, the second one is the efficiency, and the third one is the initial upfront cost. We have one, PWM stands for pulse width modulation. The second one is MPPT. This stands for maximum power point tracking. And we said the differences will be categorized into three. We have one, the mode of operation. The second one is the efficiency. And the third one is the initial upfront cost. Now we start with the mode of operation. So let's say here we have PWM, here we have MPPT. Your PWM charge controller is just an electronic switch. What it does is that during bulk charging of your battery, this charge controller switch your panel voltage to the battery voltage. Let's say the nominal panel voltage is 17 volts and the battery voltage is 12 volts, and we get fully charged at 14 volts. What this charge controller does is that it will switch this voltage from this panel. So the difference between this and this will go to waste as heat. So that's why it is advisable that if you are using a PWM charge controller, you should use a panel whose voltage is very close to your net battery voltage, because it does not have the facility to convert the excess voltage into usable current. So once it cut off this 14, the excess goes to waste. So, but during absorption charging, that is when your battery is almost fully charged, it activates what we call the pulse width, the pulse with the on and off in cycles. So the switch begin to come on and go off. It does that because the battery is almost fully charged. So it needs a small amount of power for the battery to get fully charged and to keep maintaining that charge. So it activates this. So that is where this name comes from, pulse width, the on and off of the electronic switch. So that is how it operates. The MPPT, it has algorithm. This one is more sophisticated than your PWM. It is more what? It is more sophisticated. And we can also call it the DC to DC voltage converter. Your solar charge controller is a perfect example. MPPT solar charge controller is a perfect example of DC to DC voltage converter. What does this mean? Is that it takes high voltage, the input voltage, which is high. We have high voltage slash low current. It takes this to your battery. At your battery, it converts it to low voltage slash high current. Maximum point tracking. And you know, in the principle of conservation of power, the power input must be equal to what? The power output. So if it takes a high voltage, what it does is that it converts the voltage into the panel voltage. Then the excess voltage is converted into usable current. So that's why at the end we have low voltage, high current, but the panel still, the power still remains the same. The power input still remains the same. So I will give you an instance here. If we have like a panel, 300-watt panel, let's assume what is coming out of this panel is 300 watt at 24 volts, and the current is let's say 300 divided by 24. We have 12.5 amps. Now this is what MPPT's solar charge controller does. Now we said our battery voltage is 24 volt, the nominal battery voltage, and we get fully charged at what? 14 volt. Now this is what is coming from the panel. What the MPPT does is that it will take 14 volt out of this 12 volts to charge your battery. Now the difference between your 24 volt and 14 volt will be converted into usable current. So instead of we having current, this is the same value of current, which is 12.5 amps. So the current will now increase. That means in both cases, we now divide 300 divided by 14. This gives us 21.4 amps. So you can see the power input is 300, and the end, if you multiply this and this, you will get 300. So that is how MPPT solar charge controller operates. So once it takes the voltage and it switches that of the battery, then the excess voltage will be converted into what? Excess, what is it called? Usable current. This is why it is called DC to DC converter. High voltage, low current to what? To low voltage, high current. Principle of what? Conservation of power. Power input must be what? Equal to power output. So that is just the way MPPT operates. And that is why it is different from your PWM. PWM will only take this 14 volt. Instead of taking the excess voltage and convert it into current, the excess voltage will go to waste. So that is just the difference between the two. under what mode of operation. Now we now talk of the efficiency. The second one is the efficiency. It is agreed that at conditions close to STC, standard test conditions, that the MPPT will give us 30% more than the PWM. Please, not in all situations. You understand? No, some people will just tell you that the MPPT is 20 to 30% more efficient than PWM. It's not in all weather conditions. So look out for this. At a condition that is close to STC, definitely MPPT will give 20 to 30% more power than PWM, because at this STC, your temperature will be 25 degrees Celsius. But once the temperature increases, let's say we are having 55 degrees Celsius, what happens? You know, like the initial example we gave, we said we have 300 watt solar panel at 24 volts and 12.5 amps. You know, once the, what is it called? The temperature is very high. What happens? The panel voltage begin to drop. The panel voltage drops with increase in temperature. So once the panel voltage drops, that means it is now close to that of what? To that of your battery. And since it is close to that of the battery, and that is what works best for your PWM charge controller, which PWM work better when the panel voltage is close to the what? To the battery voltage. That is why if you are installing any system that you want to use a PWM charge controller, make sure the voltage is very close. If you are doing a 12 volt system, you should get maybe panels that are around 180 watt. Maybe the open circuit voltage will be around 80 volts. Then the voltage at maximum power will be around let's say 16 point something, and your 12 volt battery will get fully charged at 14. So you see that at the end, the difference will not be much. So you don't install a 12 volt system by using a PWM charge controller, then you are buying a 24 volt solar panel. So the difference is too much. So when the weather is very hot, PWM tends to perform very well. So it will even get to an extent that when the weather is so hot that the efficiency of your MPPT will even be equal to that of your PWM, because the MPPT will convert the excess voltage. Now, if the temperature is very high in a way that this 24 volt is close to the battery voltage of what? 14 volt, MPP does not have anything much to convert again. So at the end, you see that maybe the difference in efficiency will not be much. So that's why we say in hot weather, the PWM tends to perform very well. It is used for regions that are very, very hot and for small systems. You should know this. You use them for small systems, and you must make sure the panel voltage is close to your battery voltage, because it does not have the facility to convert the excess voltage into usable current, unlike the PWM, unlike the MPPT. So that is just the main difference. Then we now talk of the initial upfront cost. Of course, we know it is cheaper. The PWM is cheaper. The initial upfront cost is cheaper. Even an MPPT charge controller can buy a PWM charge controller of the same rating 4 times over. So with this, I don't think you will have any issue designing a system when to use charge controller. Maybe if what you have on you is not much, you can decide to use PWM, and you use it if the area for areas that the weather is very cold. The panel voltage will be will be high, so it's not advisable to use PWM in such area. And secondly, for big systems, it's not advisable. You use it for small systems. And if you don't have enough budget, so these are the three conditions that will warrant the usage of this. Like I said, the MPPT is more sophisticated. It uses an algorithm to track the maximum power. Yes, it tracks the voltage and maximum power and that of the current. The high voltage is converted to low voltage, which is used in charging the battery. Then the excess voltage is converted into what? Into current. At the end, we agree that it is battery that charges the current. So if what is the MPPT is tracking from the panel is equal to what it is giving out, we say the principle of conversion of power holds. Input power must be equal to what? Output power. Please, with this, I believe we will not have any issue using this. In our next class, we'll be discussing the ratings, so how to size our solar charge controllers. Please, anything you feel about this class, drop it in the comment section. I also encourage us all to always like and share. Please like and share, and also subscribe. Hit the notification button, so whenever we drop video, you will be notified. Thank you. See you in the next class. Bye.